All right, now we're going to try to do a couple problems here in your homework on Chapter 9. And as you can see at the directions, it says write the balanced equation, and we need to pay attention to our phases, find the moles from the given amount, find the moles of the unknown, and then do all of our conversions. Give all the units, show all work, and round to the correct number of significant figures. Okay, so question number 1 says that we have 10.3 grams of sodium bromide solid. When an electric current passes through it yields what mass of bromine? So for this, because it says an electric current, you should recognize that this is going to be a decomposition reaction. Sodium is +1, bromide is -1, so this is going to be NaBr. It tells us that it is a solid and it's going to go through decomposition. So it's going to break apart into its two elements. Sodium is going to become a solid. Bromine is diatomic, which is a liquid at room temperature. Now I need to balance this. I have 2 bromine on the right, 2 bromine on the left, and now I need 2 sodium on both sides, and I have this balanced. Okay, then go back and make yourself read. So I have 10.3 grams of sodium bromide. So write that down, 10.3 grams of the substance that I have. And it says yields what mass of bromine. So again, mass is in grams, so that is going to be my X over here. So if I take a look at my mole map through what I'm going to be doing, it's going to be grams of sodium bromide, change that into moles. So always go grams to moles. Then I'm going to do my mole to mole ratio. So I'm going to go to moles of what I'm looking for, which is my bromine. And then finally, I'll be able to get it and convert it into grams of bromine. All right, so we're going to go back and start with what is given. So I am given 10.3 grams of sodium bromide. Change it into moles, I need the molar mass. So I know 1 mole of my sodium bromide is equal to 1 bromine, 1 sodium, add that together, I get 102.9 grams, time sign fraction bar. So I can take a look and see that my grams of sodium bromide cancel out. Now I'm in moles, and I want to go to unknown over known. So I look up my balanced equation, and I have 1 mole of bromine to 2 moles of sodium bromide. So unknown, 1 bromine, 2 sodium bromide, 2 moles. That's going to cancel out. And now to turn it into grams, I need the molar mass of bromine. So 159.8 grams of diatomic bromine in 1 mole. Go ahead and calculate it and round it to 3 significant figures, and you should get that it's 8.00 grams of bromine liquid. Okay, that's the first problem. And you're going to see that all of these problems are very similar. We get to homework 3, 4, and 5. We'll challenge you a little bit more in figuring out your problem solving skills. But for most of these are straightforward. So if I quickly go question number 2, we have 5.4 grams of solid aluminum reacts with how many grams of aqueous mercury 1 nitrate? So here I have aluminum, which is a solid, mercury 1 nitrate. You need to remember with mercury 1, it's Hg2 plus 2, and then NO3 is nitrate with the -1 charge. That 2 is going to stay there. So I'm going to have Hg2 and parenthesis NO3 2, and it tells us that it's aqueous. And if you step back and look at that, hopefully you're thinking to yourself that this is a single replacement reaction. So that aluminum is going to bond with my nitrate and make aluminum nitrate. Aluminum has a +3 charge. Nitrate again is -1. It's aqueous. And then we're going to get plain old mercury, which is going to be a solid. Okay, so I'm going to go back and read now, and it says I have 5.4 grams of solid aluminum, 5.40 grams of this, and it's asking how many grams of mercury 1 nitrate do I have. Okay, so now let's continue to finish this problem that I go back to what's given, and I want to write my little mole map here. So I have 5.4 grams of solid aluminum. I want to change that to moles, grams to moles. Then I need to do my mole to mole ratio. So I'm going to do moles of my mercury 1 nitrate. And then finally I will get to grams of my mercury 1 nitrate. So I'm going to go ahead and start out with 5.4 grams of aluminum, time sign fraction bar. I know that in 1 mole of aluminum, the molar mass is 27.0 grams. My mole to mole ratio, so look up at your balanced equation, which I did not balance. So I need a 3 here, and I need a 6 here, and so now my equation is balanced. So my unknown is 3 moles of my mercury 1 nitrate to 1 mole of my aluminum. And then the last step is I need to take the molar mass of that huge molecule there, which is going to be 525.2 grams in 1 mole. So go ahead and calculate this, and when you calculate, you should get 3 significant figures, and I got 315 grams of my mercury 1 nitrate. All right, so good luck with this. The next one is a kind of a doozy there to balance, but after that it's as straightforward as these last 2 that I have given you. Good luck, please work hard, come in if you need some help, and we'll see you soon.